Hello friends, welcome to my channel. In this video we will cover SSC JE solution 2020 exam date 11th December 2020 shift 1. This is part 3 of this video series. Up to question number 126 already covered in part 2 of this video series. Question number 127 onwards we will solve in this video. Question is, water is flowing in a pipe of 200 cm diameter under a pressure head of 10,000 cm. The thickness of pipe wall is 0.75 cm. The tensile stress in the pipe wall in megapascal is how much? So we have to calculate the tensile stress in the pipe wall. Thin cylinder equation we have to use. So data is given, D equal to 200 centimeter or 2 meter, pressure head P equal to 10,000 centimeter or 100 meter. Water is flowing, so density is 1000 kg per meter cube. Thickness T equal to 0.75 centimeter or 0.75 divided by 100 meter. Tensile stress we have to calculate. So thin cylinder equation we will use hoop stress or circumferential stress PD by 2T. P value we have to calculate. Pressure in terms of head given. Pressure in terms of megapascal we have to calculate. P equal to rho GH. Head given how much? Density is 10 to the power 3 into G is 9.81 into pressure head is 100 meters. So 100. How much you will get? 10 to the power 5 into 9.81 pressure Newton per meter square. So sigma T we will calculate. P is how much? 9.81 into 10 to the power 5 into diameter 2 meter divided by 2 into 0.75 divided by 100. 75 we will take, again 100. So how much you will get? 2 cancel. 9.81 into 10 to the power 7 divided by how much? 10 to the power 5, 10 to the power 9 divided by 75. We will calculate 10 to the power 7 into 100. 25 into 3, 25 into 4. 3, around 3 you will get. So 12 into 10 to the power 7 or 120 into 10 to the power 6 Newton per meter square. We will get 120 Newton per mm square or megapascal. 120 megapascal approximately this one. C is your correct answer. 130.5 megapascal. Next question. Question number 128. During suction of air in CI engine, the pressure in cylinder will be dash of atmosphere. It should less than atmospheric. Otherwise air will not go inside. So C is your correct answer. Pressure inside cylinder, it should less than pressure of outside pressure or atmospheric pressure. Next question, carbon percentage present in iron more than 4.3% is termed as more than 4.3%. So again iron carbon diagram we will discuss. 0.8% carbon, then 2.1%, 4.3 or 4.2, 4.3%, final 6.67%. Temperature in degrees Celsius, here this side carbon percent. So more than 4.3% carbon, and we know if more than 2.1%, this is cast iron, below 2.1% steel. Eutectoid point, eutectic point. (723 Celsius), 1147 Celsius. Then if you go right side of eutectic point, right side you will get hyper, left side you will get hypo. Here also eutectoid point, right side hyper, left side hypo. Left side hypo eutectoid steel, right side hyper eutectoid steel. Here also in cast iron area you will get hypo eutectic cast iron, then hyper eutectic cast iron. 4.3%. So eutected not possible. This one also. Hypoeutected less than 0.8% of carbon, and the hypereutected greater than 0.8% carbon. So hyper and hypo. 4.3% greater than, more than 4.3%, so it's hypereutectic cast iron. If it is below 4.3% of carbon, then hypoeutectic cast iron. So here they ask for more than 4.3%. So B is your correct answer, hypereutectic cast iron. Here right side hyper, left side you will get hypo. Eutectic point greater than 2.1% cast iron, less than 2.1% steel. Here in eutected point you will get pearlite combination of alpha ferrite and your cementite, and in eutectic point if you cool it you will get austenite plus cementite or lead burite. Lead burite is combination of austenite and cementite, and pearlite is combination alternate lamina of ferrite and cementite. Pearlite you will get here eutectic point, eutectoid point, and lead burite you will get below eutectic point. Next question, a rubber ball is thrown vertically upward with v velocity from the top of a building. It strikes the ground with velocity 3v. First it was thrown vertically upward. It strikes the ground with velocity 3v. The time taken by the ball to reach the ground is given by how much? So if this is a building, From building top, you are throwing upwards. And this is ground. Three points will take. Point 1. Let this is the top point. Maximum height reached. At this point is point 2. 1, 2, then ground is point 3. Ball initial velocity is v. Final velocity 3v. Then from 1 to 2, 1 to 2 we will calculate. Let u1 equal to initial velocity v, v equal to u plus at we will apply here. So v2 at point 2, v2 u1 minus g t1, because it's going against gravity, so minus g. So v2 is 0 at point 2, maximum height reached. V, initial velocity is v minus g t1. So t1 is how much? V by g. Then 2 to 3. From maximum point to ground. u2 initial velocity is 0 at point 2. v3 final velocity is 3v. So again v equal to u plus at. We will apply v3 equal to u2 plus g t2, 3v, u2 is 0, t2 how much you will get? 3v by g. Equation 1, equation 2. From equation 1 and 2, total time capital T equal to T1 plus T2. T1 is how much? V by G from equation 1, and from equation 2, T2 equal to 3V by G. So how much total time? 4V by G. So B is your correct answer. The time taken by the ball to reach the ground is given by 4V by G. Next question, dimension of absolute pressure is how much? So pressure equal to force per area, Newton per meter square, kg into meter per second square into area is how much? Meter square, kg divided by second square into meter. In MLT term, M L minus 1 length, then time T minus 1. So M L to the power minus 1, T to the power minus 2. A is your correct answer. Next question. This is a time taking question. If you know the shortcut, then go for it. Otherwise, it's better to skip this type of questions. Air is compressed in a single stage reciprocating compressor at a rate of 1 kg per second from 1 bar at 22 degrees Celsius to 8 bar. If gamma equal to 1.4 and R equal to 287 joule per kg Kelvin for air Also take 8 to the power 0.286 equal to 1.812 and ln 8 equal to 2.079. Difference in work required if compression was isentropic and isotropic. First you have to calculate isentropic work done, then isothermal work done also you have to calculate, then their difference you have to calculate. So both formula you have to use. W isothermal we will calculate. Formula is AMRT ln P2 by P1. So mass is 1 kg per second. 1 into R value how much? 287 joule per kg Kelvin. 287 into T value 22 degrees Celsius in Kelvin 295 Kelvin. 295 into ln P2 is how much? 8 bar, P1 is 1 bar. 8 by 1. Then ln 8 value given 287 295 into ln 8 is how much? ln 8 2.079. Then isentropic work done you have to calculate. Gamma by gamma minus 1 AMRT P2 by P1 whole to the power gamma minus 1 by gamma minus 1. It's a time taking process. 1.4 by 1.4 minus 1 0.4 into 1 m dot 287 into 295 8 to the power 0.286 minus 1. So how much you will get? 3.5 into 287 into 295 into 8 to the power 286. How much you will get? 1.812 minus 1. Two 87 into 295 812 3.5. If you multiply this one you will get 2.8. So difference you have to calculate. W isentropic, isothermal. 287 into 295 2.8 minus 2.079. To 0.8. So 280 300. How much you will get? 67.2 into 10 to the power 3. Here 28 into 3 you will get 84. 84 into 0.8 you will get 67.2. approximately. A is your correct answer. 64.39. Next question. To achieve maximum efficiency in practice, centrifugal pump has blades that are backward blades, bent backward for maximum efficiency. C is your correct answer. Backward curved blades. Next question. Ideal refrigeration system is used to cool the system at 5 degrees Celsius. Heat rejection happen at 100 degrees Celsius. If ambient temperature is 30 degrees Celsius, COP of the system is how much? So, ideal refrigeration system. This is a refrigerator, anti-clockwise cycle. Work done on the system. T minimum refrigerated space. T maximum atmospheric temperature. So T minimum is how much? 5 degrees Celsius or 278 Kelvin. T maximum 100 degrees Celsius or 373 degree Kelvin. Then COP of the system we have to calculate. COP of refrigerator, refrigerating effect or desired effect by watt done. This is a ideal refrigeration system. So COP equal to T minimum is our desired effect. T minimum divided by watt done is maximum temperature minus minimum temperature. So T minimum is how much? 278 Kelvin. 100 minus 5, 95. 278 divided by 95, you'll get 2.9. This is your COP. So from option D is your correct answer. Next question. Direction of a natural process is dictated by the dash law of thermodynamics. Heat flows from maximum higher temperature to lower temperature. Second law of thermodynamics. A is your correct answer. A Carnot refrigerator is used to maintain. So Carnot refrigerator or ideal refrigerator, anti-clockwise cycle. T minimum, T maximum, work done on the system, refrigerating effect, heat rejected. Used to maintain temperature at minus 30 degrees Celsius. So T minimum is minus 30 degrees Celsius. That requires 1.28 kilowatt per ton of refrigeration. So for 1 ton of refrigeration or refrigerating effect 1 ton, you have to do work done is how much? 1.28 kilowatt. So work done is 1.28 kilowatt. For refrigeration effect 1 ton. 1 ton equal to 1 ton or 3.5 kilowatt. The heat rejected in kilowatt per ton of refrigeration is how much? So heat rejected value we have to calculate it. Heat rejected, it's equal to work done plus your refrigerating effect or desired effect. Work done is how much? 1.28 and refrigerating effect per ton of refrigeration. So it's 1 ton or 3.5 kilowatt. How much you will get? 4.78 kilowatt. 4.78. C is your correct answer. Strain has dimension. Strain change in length to original length. Length by length, m to the power 0, t to the power, l to the power 0, t to the power 0. C is your correct answer. On TS diagram, constant pressure line slope is expressed as. So TS diagram, TS plot, constant pressure line, slope we have to calculate. Theta we have to calculate. See ds dt. TS diagram, heat transfer area equal to this area of TS diagram. So dq for this small area or small triangle, T into ds, or dq equal to T into ds dq for constant pressure process, Cp dt for unit mass, m Cp dt, or for unit mass Cp dt. You will take dt by ds equal to T by Cp. This is equation 1. Then from this triangle, tan theta equal to dt by ds. Small value of theta. This is equation 2. So from equation 1 and 2, theta equal to T by Cp. Theta is your slope, it's equal to T by Cp for constant pressure process. B is your correct answer. And for constant volume process, your dq will get Tds equal to Cv dt. Then here you will get T by Cv. And final answer you will get T by theta equal to T by Cv for constant volume process. Constant volume. Both you have to remember. Dot is produced in locomotive boiler. Locomotive boiler, dot is steam jet dot. A is your correct answer. Which of the following does not require flue gas for operation? Economizer we know. Flue gas is required. Superheater also flue gas is required. Air preheater or preheater also flue gas is required. So B is your correct answer, injector. So this is the end of part 3 of this video series up to question number 150. Question number 141 onwards we will solve in part 4 of this video series. Thank you friends. Thanks for watching my video. Thank you.